For this problem, we're asked to use a change of variables to evaluate this definite integral. So we're going to use a change from x to u's. That's kind of what they're talking about here. Basically, it's u substitution. Let's see if I can spell substitution correctly. Yep, there we go. U substitution. All right, so let's go ahead and write down our integral. But what I want to do is use a 1/2 for the exponent, because I don't know what to do with the square root, right? Okay, so let's start out by setting our u to be 1 minus x squared, the inside part, and then my du is negative 2x dx. So I have the x dx, where this is my u, x dx, but I need that negative 2. So if I multiply by a negative 2 there, I need to compensate for that and also divide by negative 2, which is the same thing as multiplying by negative 1/2. Okay, so I have these two pieces being equal to du. This in here is my u, so that'll be u to the 1/2. So I've got negative 1/2 integral u to the 1/2 du. All right, so now I need to get my new bounds of integration. So I have x equals 1 and x equals 0 as my bounds of integration in terms of x's, but I need them in terms of u's now. So if I have x equals 1, that means u, using this, will be 1 minus 1 squared, which is 0. And then if I have x equals 0, I get 1 minus 0 squared, which is 1. That's interesting. They just swapped. So in terms of u's, I'll have 1 to 0, which is really odd. We need the top number to be the larger one. So what happens is if I switch those bounds of integration, I multiply by a negative. Okay? So swap those around, and then I multiply by a negative. So in other words, this negative 1/2 became positive 1/2. All right, so now I'm on the right track. So I can go ahead and integrate. Let's find the antiderivative of u to the 1/2. So we'll take that exponent of 1/2 and add 1 to it to get 3/2. Okay, so I'll end up with u to the 3/2. And then I need to divide by 3/2. So in other words, that 1/2, this 1/2, I'm dividing by 3/2, which is the same thing as multiplying by 2/3, which then reduces to 1/3. Okay, evaluating from 0 to 1. Let me just separate all my side work there. Okay, so if I plug in a 1, I get 1/3 times 1 minus what I get when I plug in a 0, which is just 0. So it looks like my answer ends up being exactly 1/3. So that's the area under this curve on the interval 0, 1.